with the topic. The topic is like we got multi-threading in the last class. So today we will start with some of the other concepts which you might have to know. In that one of the topic is like, in that one of the concept is like, you should know about what is cloning. We'll see, just first understand about what is cloning. Okay, I'll talk about what is cloning. Then you'll understand about what is shallow cloning, what is deep cloning, and where cloning is required. Okay, we'll take up an example. Just first let's explain about what is really cloning. Then we'll go further to discuss what is shallow cloning and deep cloning, the two types of cloning. Then we'll talk about a concept like what is serialization and what is deserialization. Okay. So these things that you must be aware of. That's why we are going to discuss specially about these topics and what is enum. So these kind of things I just want to cover in the session today. Okay. See. First, let's start with what is cloning. I think you can able to see my screen.
Yes, sir.
Okay, I'll continue. Sure, I'll continue. Guys, what we're discussing is we know about the concept of what is cloning. Basically, nothing to do
Sir,
with
your voice is
this
breaking.
with the same properties, which is called as blueprint. We can call it. Okay, so we are going to further discuss about this cloning part.
Sir, your screen is not visible.
Just a minute. Yeah. Now is it okay now? Can you?
Yes,
Is
sir.
it
Now
okay?
you are audible.
Okay then. Good. So we are going to start with the concept of cloning. Okay, we are going to start with the concept of cloning. So we want to know about really what is cloning. Okay, cloning is nothing but creating a duplicate object with the same properties, but it should be independent from the original object. Okay, so it is basically it's a process of creating. Okay, I can say something like it is the process of creating a duplicate object, okay, from an existing object. Okay, that is what actually called as cloning. It's a process of creating a duplicate object from an existing. Okay, it's a process of creating a duplicate object from an existing object. Okay, which is nothing but what you want to create exactly the same copy of existing object with the same properties, or we can say you want to create a blueprint for the existing object, we can say. Okay, correct. So you want to create a duplicate object with the same properties, but it should be independent from the original object. So then it apply cloning. We'll see examples like where cloning is required. Right. So it's a process of creating a duplicate object from an existing object. Okay. So when you clone an object, okay, a new object is created with exactly the same properties and exactly with the same behavior of an existing object, but it is independent from the original object. Let me talk about that. So basically the thing is when you clone an object, what happens? A duplicate object is created. Okay, when you clone an object, a duplicate object is created with the same properties. Okay, with the same properties and with the same methods. Okay, is created with the same properties and with the same methods. Of an existing object of existing object only. Okay, with the same properties and with the same methods of an existing object, but it is different from the original object, or independent from the better word, but it is independent from the original object, independent of the original object. Okay, so it's a process of creating a duplicate object from an existing object. So when you clone an object, a duplicate object is created with the same properties and with the same methods of an existing object, but is independent of the original object. That is what actually called as cloning. Now let us understand where we need this kind of cloning. Actually, when object creation is a complex task, then we are going to apply the concept of cloning. Okay. Let's see. For example, I mean, just I'm talking about mostly if you look at some gaming applications. Suppose mostly when we are creating some gaming applications, we are going to create some kind of duplicate objects from the existing objects. Good. Okay, it is independent of the original object. So basically, when you are working with gaming applications, what happens in gaming applications is you need some multiple instance of complex objects, right? For example, there is a complex object you want to create in gaming application. Okay, and multiple instance of the complex object is required with the same characters or with the same assets. Okay. For example, in gaming applications, we create some enemies. Okay, for example. So what I'm saying now, in a game application, there are multiple enemies for the hero. But those multiple enemies are of looking same type. Right? So what does it mean now? Instead of recreating them from scratch, that each enemy instance, we first create one enemy prototype and we create multiple instances by cloning it. So that's how the cloning will be. So multiple instances of complex object can be created with the same characteristics, or we can say the same characters, without having to recreate those objects from scratch. That is called prototyping, and this comes under cloning. Okay, and for example, if you look at about some kind of creating the backups, data backups. First, I want to create a backup for the data to maintain the data integrity when the data is critical or crucial. What I can do now? First, I will create a backup. There is an object with data. First, I'll create a backup of the data, means I'll create a clone. Then the operations will be carried out on the original object. Okay. So first I want to maintain one backup. Then operations will be carried out on the original object. Okay. So in this case also, for doing that kind of data backup, we just clone the existing object. There is an object with the data. First we'll clone it. A duplicate object is created with the same data. Now operations are carried out on the original object. So this cloned object will be looking like a backup copy. For example, in future, if something happened for the original object, the data can be reloaded from the duplicate object. That's how the cloning works. Okay. So these are some of the examples. So when object creation is complex, I say when object creation is complex, nothing but when you're creating complex objects, instead of recreating from scratch, or simply I can say that while creating complex objects, okay, while creating complex objects, instead of creating them, instead of creating them from scratch, instead of creating them from scratch, we can clone an existing object. Okay, we can clone some existing object to create multiple instances of our complex objects. We can clone an existing object to create multiple complex objects. Let's say, for example, okay, for example, now what's the example? Let's say, okay. Now let's go ahead. Now what I'm talking is now, for example, I want to write in the gaming application. So gaming applications are data backups, whatever it is. Okay. Now, see, for example, in game development, what game development, multiple enemies we need to create, right? Multiple enemies to be created with the same characters, or we can say the same characteristics, whatever it is, I can say the same character with the same characteristic. We need multiple enemies, correct? We need multiple enemies with the same characteristics. Okay, we need multiple enemies with the same characteristics, or with the same characters or characteristics. Okay, we need multiple enemies with the same characteristics. So what we do? So we create, okay, one prototype enemy, nothing but one original object. One prototype. Prototype means just a sample, we can say. One prototype object, and we clone that prototype to create multiple enemies. We create one prototype enemy and we clone it. Okay, and we clone it to create multiple enemies. Okay, this is how the cloning works, for example. And similarly, I told you for data backups also we use cloning. Now how this is happening, that's what we are going to discuss. Coming to programmatic requirements now. So basically what happens when you are cloning is, there is a duplicate object is created for original object, but that duplicate object is independent of original, which is nothing but if any changes are made to original object, it doesn't affect in duplicate object, or if any changes are made to the duplicate object, it doesn't affect in original object. I'm going to show you with the code. Okay, right. So basically the point to better to notice, okay, the point to better to get the point is, the point which I want to write is, the point which I want to write is, once a cloned object is created, okay, from the original object. Okay, once a cloned object is created from the original object, both the objects behaves like independent objects. Behaves like the two independent objects. Okay, right? Both the objects behave like the two independent objects. It means, okay, it means the changes made to the original object. Okay, the changes made to the original object doesn't affect the what? The changes made to the original object doesn't affect the cloned object. And vice versa. Okay, so these are all the statements which are with respect to the concept called as cloning. Okay, these are the different statements that I wanted with respect to the cloning. Let's see with an example. Then we'll discuss about what are the different cloning types. Okay, let's say for example, two objects are there. Let's say for example, there are two objects are there. This is the original object. Let's say for example, this is the original object which contains a value of x. Original object. Okay, original object. And original object contains a x property. Let's say there is an x property and the x property value is 10. The value of x is 10. Let's say x is equal to 10. Okay. So when I create a clone, okay, when I create a clone, then one more object is created, which is called cloned object. Now let's say this is a cloned object. Say this is cloned object. Okay. At the time of cloning, cloned object will get the same properties and same behavior from the original object. X is equal to 10, but both are independent. What happens now? If, for example, I say original object dot x is equal to 20, means I'm modifying the data in original object now. It doesn't affect in cloned object. Okay, which means I'm writing, for example, original object. First, just only I'm writing, this is only for your understanding. Original object dot x is equal to 20. If I make changes to original object, doesn't affect in cloned object. If I make changes in cloned object, doesn't affect in original object. Original object dot x is equal to 20. Now what happens now? I will get the original object again. Let me write both. Let me take the diagram again. I got my diagram again. Okay. I got the diagram again. What I'm saying here, x becomes 20 here. But in cloned object, x becomes 10 only because it's not affected the original cloned object. If I make any changes to cloned object, doesn't affect in original because both are independent objects. Okay, that's how it works. Now, how can we clone the object? Okay. So how can we clone an object? Okay. See, if at all you want to clone the object, there are two things to follow. One is you need to override clone method of object class. If you want to clone object of a class, that class must override clone method of object class. Okay. I mean, what I'm trying to say once again, if you want to clone an object, first of all, that class must override clone method. And one more thing is, if the object is a clonable type, then only clone will be supported. There is an interface called clonable, which is a marker interface. So the class must implement a clonable interface. Clonable is a marker interface. You no need to override any method. Just implement the class from clonable interface. That's the first thing. Now override clone method of object class. Why? Because while cloning an object, first of all, okay, while cloning, first of all, the JVM verifies is this object is a clonable type or not. If it is a clonable type, then only it will clone, otherwise it won't clone. So how to make my object as a clonable type? Okay, how can I make my object as clonable type? For that, there is an interface given called clonable. So we need to implement clonable interface. Remember, clonable is a marker interface and a clone method is from object class. Don't feel that clone method is from clonable interface. Clone method is not from clonable. Clone method is from object class. Clonable is a marker interface. It doesn't have anything. It is empty. Okay. So I want to, okay. So I just want to tell you this. How can we clone an object? I'm going to show you with an example, but first let me talk about. Okay. So how can we clone an object? First thing is what? Okay. First, we have to implement. First, we have to implement our class whose objects you want to clone. First, you want to implement our class whose objects need cloning. We have to implement our class whose objects need cloning from java.lang.clonable marker interface. From a marker interface, java.lang.clonable. That's the first thing. Okay, we have to implement our class whose objects need cloning from a marker interface, java.lang.clonable. That's the first point. Second thing is, okay, second, so we have to override the clone method Second, we have to override the clone method of object class. So why we should override clone method of object class? Actually, clone method is there in object class. Clone method is a native method, which means clone method logic is written in C language. We cannot write actually our own logic for cloning. Okay, we can't write the logic. We cannot write our own logic for cloning to create a duplicate object. Cloning is a process. It is like a OS level process written in C language. That is called as native method. Native method means a method in Java class, but its code is written in C language. That is called native method. A method belongs to Java class method, but its implementation or that method body is defined in using C language. That kind of methods are called as native methods. Clone is a native method. So we cannot write the cloning logic. We have to call again object class clone method only. We have to override the clone method, but we cannot write the logic. We have to call the superclass clone method only. So then why should I override clone method in my class? Because when I'm calling clone, the type of the object, it uses the object through which this clone method is called. First, it will verify is that a type is clonable type or not. So for that reason, we have to override clone method. It is a bit internal concept, but basically what we need to do is we have to override the clone method of object class. Is a second thing. What is the logic we write instead that we cannot write the cloning logic? Again, we call the cloning logic available in object class only. So first override the clone method and call the superclass clone method to clone the object of my class. And while I'm calling the object, which object I want to clone, first that object type is verified, whether it is a clonable type or not. And yes, if it is a clonable type, then that object clone is created and that cloned object will be written by the clone method. That's how it works. It is a different thing, but anyhow, you should know just first of all how we can able to implement the cloning concept in Java. Okay, we will discuss. So it's a different concept now. Of course, in coding you will understand a bit more. Let's see an example of understanding how it can be done. Let's start our workspace. Okay, let me check. I'll show you the example like what. I think I have in another workspace. I'll switch to one more workspace I have. I'll check. I think I have an existing example. Otherwise, I'll write the code now. I'll show you an example. I think I have an example. If not, I will create now. It's not a problem. Somewhere I have this example for cloning. Instead of writing that example, I just want to is that example. Is there another workspace? So it's not there. I will start writing the new code. No issue, not an issue. I think in this machine it's not there. I'll start writing the code. Don't worry. Just we'll see. I will simply write a class A, and with only the two properties X and Y. And we will clone the object and we will see whether the cloning is working like that or not. Okay. Let's see how it works. Let's say, for example, I'm writing one new project. And let's say, for example, it is the cloning test. Okay. So I'm creating one cloning test program. Let me show you. First, what I do is I just want to write one class, right click new. Then I just want to go with the class. Of course, I'll write the package name also. Package name can be any name. Let's say, for example, com.ashokit.cloning is the package name. Package is nothing but a group of classes. So here, let's start with the class name. Let's say class name is main. Now, above this main, I want to start writing my class. Let's say class A. It has two properties. Let's say private int X, private int Y. I want to define a constructor, class A of two parameters, int X comma int Y. Sn this dot X equal to X, this dot Y is equal to Y. Okay, this is how I'm writing. And simply I just want to over a toString method to display the data. That's over a toString method. Okay, I'll right click, go to source, then generate toString method. Then the toString method, I also want to generate setters and getters. ToString method is okay. Then I want to define the setter getter methods for this. Okay, generate the setter getter methods also for this. Generate getters and setters. And this is a class A. Requirement is what? Now this class object I want to clone. For example, see, I just want to create object of class A first. Class A, CA is equal to new class A. I'm creating an object. And I'm passing two parameters, let's say 10, 20 to the constructor. Okay. So class A, CA is equal to new class A of 10, 20. Now I say, for example, CA.clone. If I'm trying to call .clone, I'm getting an error at line number 40 because actually clone is a method in object class. Let me open the object class now. In this object class, we can find clone. clone method. Okay, let me directly type clone. Now we can see there is a method called clone. Okay, clone is a native method. Clone is a native method. Moreover, clone is protected method. Directly we cannot call clone because protected method is visible only to the child class. Okay, but my class is child class only because every class is a child class of object class. The default parent class is object only. But still, when I'm trying to call dot clone method, it is not showing me any option. It is simply going to give me error, but it's not going to show me any answer. See, when I'm trying to write here, ca.clone, I'm getting an error. You can see the error. The method clone from the type object is not visible. Actually, protected methods are visible. Protected methods are visible to the child class of different package also. But why it is not visible is because of native. So directly we cannot invoke the clone method of object class. And moreover, because of semicolon, you don't feel that it is an abstract method. It is not abstract method. It is a native method. There is no abstract keyword here. Object class is not abstract class. It is native. Okay, there is a big definition here. The method clone for class object performs a specific cloning operation. If the class of this object does not implement the interface clonable, then clone not support exception will be thrown. Okay. So thing is, first understand this is not it's protected method. Actually, protected methods are visible to the subclass, but clone method is not visible because it's native method. It's native method. Native method in the sense it's the code defined in we can say C language. Okay, so that's kind of methods are called native. Native is a keyword, and if at all I want to clone the object of a class, the process to follow is first I need to override clone method in my object class. In my class. In my class, what's the class name? Class A. This is the class of this object CA. So in this, I need to override clone method. Let's say I'm overriding clone method here, for example. Override method in object. Okay, clone method. I'm overriding clone method. Do remember return type of the clone method is object. Clone method throws clone not support exception. Now I'm writing super.clone. Super.clone means we are calling the clone method of parent class because native methods can be called. Native methods we cannot. Native methods are not directly called. We have to override the native method in our class, and then we can call the native method of the superclass. That's how we are doing. So return super.clone because clone logic we can't write. We have to call the clone logic of the native method logic only. Next, when I call super.clone, what the super.clone returns? Object. Actually, cloned object is my class A object only. It clones object of class A only, but returns like a object type. So we need to typecast it into class A type. The logic we cannot write. I mean, that's a native method. The logic is already, JVM has the logic of this clone. Cloning logic will be there in JVM. There are native libraries in JVM. So that native libraries of JVM contains the cloning logic that is written in C language. So when I say super.clone, the clone method of object class we are calling, which is a native method. So native method logic is there in JVM. So at runtime, JVM will execute that cloning logic. But before executing the cloning logic, first it will verify the class of this particular object is clonable type or not. Otherwise, it will throw clone not support exception. So for example, now I am not implementing clonable. I write now, for example, ca.clone. Because clone method throws clone not support exception, it comes under checked exceptions category. That's why I'm writing main method also throws, because if any checked exception is thrown from a method, the caller method has to either handle the exception with a try catch blocks. Otherwise, it can also declare, propagate the exception to its caller. Its caller means main method caller is JVM or JRE, throws clone non support exception. If I run this code now, I'll get exception clone not supported. I got exception clone not support exception. So why I'm getting this exception? Because the class of this object, who is the class of this object CA? That is class A. The class of this object is not a clonable type because I'm not implementing from clonable. I'm not implementing this class from clonable interface because it doesn't implement a clonable interface. It is not a clonable type. So JVM will check before executing the native method logic, that is clone method logic. First, it will check the class of this object is a clonable type or not. The objects of type clonable only will get the facility called cloning. They get additional behavior called cloning behavior. That's what marker interface purpose. So I'll let implements clonable. Now cloning is supported, but clone method returns object. What can I do now? I can actually, it clones. Okay, it is going to create a copy of CA. It's going to create object of CA only. A copy of CA, nothing but a duplicate of CA, of this object CA. But returns like object superclass. So we have to typecast it. So what I'm doing, class A cloned CA. I'm writing something. Cloned CA is equal to typecast class A of CA.clone. Now I write system.out.println original object CA, display the CA, system.out.println cloned object. This is called cloned CA. Both of them are having same data. The duplicate object also will get with the same properties and same behavior of original object, but it is independent from original. Let's see whether it's independent or not. Now, as you can see, original object contains x20, y20, sorry, x10, y20. Cloned object also contains x10, y20, same as it is. That's how cloning. Now, the other object is created. But while cloning, constructor is not executed. Without executing constructor, object is created. When creating cloned object, constructor is not executed. If you want to verify it's really executed or not, let's say, for example, we will let SOP statement. SOP class A constructor. Class A of int comma int constructor. Let's say 2 parameters constructor. If I run this, only one time we can able to see this message, because while creating the clone of this object CA, constructor of the class is not executed. Without executing the constructor, okay, without executing the constructor of the class A duplicate object will be created, because it is written in C language. It is not written in Java. While creating the object, constructor must be executed. That clone method logic is defined in C language. So it is not just going to call the construct of the class while creating the clone object. So construct will execute only for original object, not for cloned object. While creating like this, with new only the constructor is called. But this clone doesn't use new keyword. New is from Java. It uses C language code. That's why construct is not executed. Without invoking the construct only, another copy of the existing object is created using C language code. And the same data will be dumped. The same data will be copied to the new memory. That's why the construct is not executed. Now, if I run this code, you can see the constructor is executed for one time only. That is while creating the object with new keyword. But while cloning, the constructor is not executed. That's why you are getting message only one time. You got the message just for once. That's how it works. Next. Let's see one thing. Okay, I have shown you, just I want to keep this in comment. The other thing is like, there is something called, let's say, I want to make changes now. Make changes to original object. For example, CA dot set X of 30. X value 30, set Y of 40. X value 30, Y value 40. Set X of 30, set Y of 40. Now, after making changes, now let us again display original object and cloned object. I want to give some separator. Now let's say SOP of original object, SOP of cloned object. The two statements once again will write. If you make changes to original object, doesn't affect in cloned object. Or if you make changes to cloned object, doesn't affect in original object. That's how cloning works. Now we can see here, original object values are changed to 30 and 40, but cloned object still contains values of X value 10 and Y value 20, because cloned object is independent from original object. The changes made to original object doesn't affect in cloned object. The changes made to cloned object doesn't affect in original object. This process is called cloning. Okay, you can just test this code. For your reference, I'll copy into the document next. I'll start the document, then I will copy it. Next. Let's open the document. So here we started with a concept called as cloning. This is a cloning document, and today's document contains everything, cloning, all. First, I will copy this picture. Whatever the statements I've written, all these things I want to copy first. I'll go to my document. First, I'll insert this picture. So now you got to know something about this cloning. So then here I want to copy the example. Let me copy the example here. And better, I'll also copy the output. Okay, output. So that's how it works. Now this is, you got to know just how the cloning works. Now we are going to discuss about types of cloning. Okay. There are two types of cloning now. When you talk about types of cloning, cloning is of two types. I'll tell you. One is called shallow cloning. Second one is called deep cloning. Difference is very simple. What happens in shallow cloning is when you clone a dependent object, its a dependency object will not be cloned. When you clone a dependent object, its a dependency object will not be cloned. What happens now? Dependent object, dependency object, original object, cloned object, both will share a single dependency object. If you want to clone a dependent object with including its dependency object, then we need to apply deep cloning. That's how the difference is there between shallow cloning and deep cloning. Let's see an example. First, I'll try to add the statements and diagrams here. So I'm talking about shallow cloning. What happens in shallow cloning? Let's say, for example, this is my, let's say this is my dependent object. Let's say this is original object of class A, which contains X and Y. This is original object of class A. Let's say original object of class A. Now let me write something like this, class A. This is what original object of class A. It has values like X is equal to 10, Y is equal to 20. This is original object of class A. X equal 10, Y is equal to 20, original object of class A. Now, for example, there is a duplicate object also created for. Actually, this class A has class B object as a dependency. Let me write arrow like this. Let's say this is class B object. Let's say this is class B object. Okay. Thing is, class B object contains, for example, A is equal to 100, B is equal to 200. It has two properties called A and B. Now, I'm cloning this class A object, not class B. Class A object is dependent object. It has class B object as a dependency object. Now I'm cloning the original object. Okay, I'm cloning the original object. Original object means class A object. In shallow cloning, what happens? The original object and the cloned object both will share the same dependency object. That's called shallow cloning. Which means, let's say there is a cloned object here. Let's say, for example, this is a cloned object. Cloned object of class A. This is cloned object of class A. This is what cloned object of class A. And here we have the data like x is equal to 10, y is equal to 20. Okay, right? Now what I'm saying now, both objects are going to share the same class B object. This is called as shallow cloning. So when you clone an original object and the cloned object, both are going to share the same dependency object in shallow cloning. Which means only the dependent object is cloned, but its dependency object is not cloned in shallow cloning. But whereas in deep cloning, both are cloned. Let's see how. The diagram, same diagram. Better. First I'll keep here. Let's see the next diagram. We'll copy the same diagram. For one more time. This is shallow cloning diagram. And coming to deep cloning diagram. What happens in deep cloning? I'll remove this arrow. That's how it works. This is called deep cloning. Okay, the diagram will automatically tell you what is happening here. In deep cloning, when you clone a dependent object, its dependency object is also cloned. Now this becomes class B cloned object. This is called deep cloning. But in deep cloning, dependency class also must support cloning. Nothing but dependency class also must implement a clonable interface. Just not the dependent class. Even dependency class also, if implements clonable, if it overrides clone, then only deep cloning is possible. So who is the dependent class here? Class A. Who is the dependency class here? Class B. Class A is a dependent class. It depends on class B. So class B is a dependency class. So this first diagram is called shallow cloning. The second diagram is called deep cloning. This is shallow cloning. And now this is called deep cloning. Okay, that is the first one is called shallow cloning. This is called deep cloning. That's how the shallow cloning and deep cloning are different. Let's see. But first, we need to add some point. What's the point here? The point for you is what? In shallow cloning, when a dependent object is cloned, dependent object is missing. When a dependent object is cloned, it's a dependency object. Okay, will not be cloned. It means both original and cloned dependent objects will share the same dependency object. That's called shallow cloning. But what happens in deep cloning? So in deep cloning, when a dependent object is cloned, right? When a dependent object is cloned, what happens in deep cloning? When a dependent object is cloned, its dependency object is also cloned. its dependency object is also cloned. So the original and cloned dependent objects will have a separate dependency objects. Okay, that's how the difference is there between shallow cloning and deep cloning. Am I clear with you? Did you understood this point? Did you understood my diagram first of all? What is shallow cloning and deep cloning?
Yes, sir. Understood.
So this is going to be the shallow cloning diagram, and that is going to be the deep cloning diagram. We will see how shallow cloning and how deep cloning can be implemented. Let's keep this diagram into the document. So here is my picture to insert. I want to insert this picture, right? Okay, so you got to know how the shallow cloning and how the deep cloning works. Now let's see with our example. Let's create something called as same example, but we will start writing shallow cloning example separately, deep cloning example separately. Let me create a new project. I'll copy this code, but first let me create a shallow cloning program. Let's finish shallow cloning program. So in the shallow cloning program, first I want to start writing something called as what is that? I want to start creating a new class. I want to name the class as main. Package name same com.ashokit.cloning. Okay, let's click on finish. I want to start two classes here, class A and class B. First, let me take class, the previous code from example. This is class A. Let's copy this. This is class A. But class A is a dependent class. It has class B as a dependency. Let's say private class B. Of course, class B is not yet created. I'm going to create it. Class B, class B. Okay. In the constructor, I will create the class B object. Class B is equal to new class B of, in the constructor of class A, I'm creating class B object. Class B equal to new class B of, let's say for example, 100, 200. Means I'm just going to create one class called class B with two parameters in the constructor. So let's start creating the new class B. It has two variables, private int A, comma B, otherwise private int A, private int B. Then I want to define a constructor, class B of int A, comma int B. This dot A is equal to A. This dot B is equal to B. And yes, I want to override toString method. To return the values of A and B. I mean, I want to generate toString method. Source, only toString. Setters, getters are not required for me. Just toString is enough. Okay, just toString is enough. I don't want setters and getters. Only toString method is enough. That's it. This is class B. We know that class A is the dependent class, and we are creating class B object inside class A. So class A is a dependent class, and class B is called dependency class. Now class B is not implementing clonable interface, and it doesn't have any clone method. So we are going to clone only object of class A, which is shallow cloning we are doing now. For deep cloning, dependent and dependency, both classes must implement a clonable interface. But for shallow cloning, only dependent class should implement a clonable interface. So my dependent class is class A. When I clone this object, when I clone object of class A, the cloned object and the original object both are going to share the same object of class B, the same dependency object. Dependency object is not cloned, so it is no need to implement a clonable interface here because we are discussing shallow cloning. So class A is a dependent class. It's a dependent class. It's a dependent class. It depends on class B. So class B is a dependency class. Okay, now coming to main. We need main method. So let's start writing the main. Main method. We will public static void main method. Tell me, in this main now, okay, in this main now, I want to create object of class A, then I want to clone it. And in the toString method of class A, I want to display the class A, the properties of class A, and also the class B, because class B is also a member of class A. It is a member of class A. So I want to override the toString method of class A for one more time. It should include class B also. So just I want to override toString method of class A, which means it should print X value, Y value, and class B also. That's why I'm overriding toString method again. Now here I want to create object of class A first. Let's say class A, CA is equal to new class A of 10, 20. Okay. Next, what I say, class A cloned CA equals to typecast to class A of, because return type is object, clone method return type is object. And clone method throws clone not support exception. So our main method also should, because it is checked exception. Our main method should either it can handle with the try catch blocks, otherwise it can also propagate using throws keyword. Clone not support exception. This is how it works. Now we want display both objects. What and what objects? What and what objects? Cloned object and original object. And one more thing, to show you that yes, both are sharing the same dependency object, let's do one thing. We'll define setter getter methods for A and B. Right? So I'm defining setter getter methods also in class B for both the variables A and B. I'll show you what I'm trying to tell you. Now, first I want to display. What I want to display is system.out.println original object. When I display original object, its dependency object will also be displayed. Okay. Then system.out.println cloned object. Cloned CA. Okay. Now I want to display one separator. Now what I'm doing now, I'm making a change in the dependency object. Dependency. Okay. What I'm doing, I'm making a change in the dependency object through original object. Who is the original dependent object? CA. Through original dependent object. Who is the original dependent object here? CA. So CA dot get class. For class B, I need setter getter method so that I can get the class B object. See, I have three variables now in class A. One is X, Y, and class B. But setter getter methods are generated for X and Y, but not for class B. That's why I want to generate the setter getter methods for that one also. Okay, so what get class B returns? Class B object now. So what I call here? I'll call CA dot get class B dot set A of 99. Okay, 99. Next, CA dot get class B dot set B of 199. Okay, you got the point, right? CA dot get class B dot set A of 99. What is the first of all, I have a question now. Did you understood my statement? Do you know what I'm trying to do now?
Yes, sir.
Okay. What about the other guys? Did you understood what I'm trying to do actually? What I'm trying to do, did you know? Who is CA?
It is the object of class A.
It is the original object of dependent class, that is class A.
Yeah.
Okay. Dot get class B. What this method get class B returns?
Returning the object of class B.
Returns the class object of class B, the dependency object. Then on the dependency object, I'm modifying the value of property A and property B. Actually, their values are 100, 200, because the constructor, I'm giving 100, 200. But now I'm changing them to 99 and 199. I'm setting the value to 99 and 199 through which object? Original object. But I want to display through cloned object. Let's see whether the changes affected in the cloned object also or not for the class B, the dependency object, because both are sharing the same dependency object.
Yes, sir.
That's why I want to show. So system.out.println of again original object. Display CA. Then what? System.out.println of cloned object. Cloned CA. The thing is, I'm modifying through original object, but affected in cloned object also, because original and cloned both are sharing single dependency object, the same copy of the dependency object, single copy, because it's a shallow cloning example. It's not a deep cloning. Let's see how we can able to understand this output. Let's see how we can able to understand this output. Okay, let me write. Now, as you can see here, this is the original object. And this is the cloned object. But original object, cloned object, both are containing same dependency object. And after making changes through original object, but still the cloned object also will get the same changes. Because both are sharing the same dependency object. Because a dependent object is cloned, but dependency object is not cloned because of it's a shallow cloning example. So in shallow cloning, dependent class implements clonable, dependency class doesn't implement clonable. I mean, it no need to implement clonable simply in shallow cloning. That's how we need to understand. Okay. That's why my class B is not implementing clonable. It's a dependency class, but class A is a dependent class. It implements clonable because we are only cloning the dependent object, not the dependency object. This is shallow cloning. Let's see how the deep cloning. Now, deep cloning is a bit different. It's not like simple because dependency, both the classes should implement clonable interface. Then only deep cloning is possible. The point is, in shallow cloning, right? What I'm saying is, in shallow cloning, dependent and a dependency. Sorry, not dependent dependency, only dependent. Okay, in shallow cloning, dependent class. Okay, in shallow cloning, dependent class implements clonable interface. But not the dependency class. In deep cloning, both. In deep cloning, we are going to see the next example. In deep cloning, both dependent class and the dependency class. Okay, both the dependent class and the dependency class should implement clonable. This is first example is shallow cloning example. Shallow cloning example. I'll copy paste the shallow cloning example. That's what we discuss now, and I'll also show you the output. This is shallow cloning example and output. Next, we'll make it as a deep cloning example. In same code I'll copy, I'll get a separate project, but the same code I'll copy, I'll show you how the deep cloning works. This is shallow cloning example. Now we'll understand about what deep cloning example. Let's see how the deep cloning works. Okay, folks, let's try. Now see. Let me do one thing. I'll get a separate project, not the same project. Let's say deep cloning program. Okay, deep cloning program. It's not shallow cloning, it's a deep cloning program. Let's go ahead. The same package I'll copy. I'll paste here. But this time we are going to implement deep cloning, not the shallow cloning. So this is a dependent class and this is a dependency class. So dependency class also must implement clonable. And it also must override clone method. It also must override clone method. It also must override clone method. Okay, dependency class also should implement a clonable interface and it must override clone method. Now, when it comes to dependent, it should return cloned dependent object with a cloned dependency object. So in the clone method, we need to make some changes now. Here the changes are required here. Let's see what the changes required. See what this dependent class clone method has to do. It has to return cloned dependent object by setting cloned dependency object. It should return a cloned dependent object by setting cloned dependency object. So first get the cloned dependency object. How? See, class B cloned B is equal to typecast of class B of class B dot clone. First I am calling clone method of class B. I am getting the cloned class B object now. Cloned B object. Now, observe here. Class A cloned A equal to class A of super dot clone, which means I am getting the cloned A object by calling super dot clone. To the cloned object of dependent class, set the cloned dependency object. Means what? Cloned A dot set class B of cloned B. Return cloned A. So please digest this clone method. I'll give you 2 minutes time. Find out if you have any query, then you can raise your question. Understand, digest this method. First, understand what I'm doing there. What is deep cloning and what I am doing. Just correlate the deep cloning concept and the logic of this clone method. You just digest that so that we'll go further. We'll move further. Okay. Okay. Are you done?
Sir, can you please explain the line number 19?
Sorry.
The line number 19, class A cloned A equals to class A super of clone. Can you please explain once?
See, if you want to clone the object of class A, what we need to call generally super dot clone method only. Na? If I want to clone an object of a class, I have to override the clone method, then I need to call the super dot clone, right? Because clone logic is defined in native language. I'm calling super dot clone. Super dot clone means I'm calling the object class clone to clone the object of class A. This is to clone the object of class A. This clone method I'm calling from class B. Because class B also has a clone method to clone the object of class B. How to clone the object of class B? Again with super.clone only.
Yeah. Yes, sir. Getting.
Okay. You got it right now? Good. Okay. Now, the same code. Let's see what's going to happen after making changes in dependence object to original dependent object now means class CA object. CA means original. But it doesn't affect in cloned because CA and cloned CA both have separate copies of class B, separate dependency objects. For CA, it is changed to 99, 199, but for cloned CA, it is going to be 100 and 200 only. It is not changed to 99 and 199 because the copies are different. That's what I want to show. This is called deep cloning. So let's try to execute the program and see the output. See the difference in previous code to current code. You can find some difference now between this previous code and current code. Previously, you got both places 99, 199, but here we got 99 and 1 for original object, but for cloned object, it is 100 and 200. It's not changed to 99 and 199. Because the cloned dependency object is different from original object to cloned object. Original dependent object, cloned dependent object, dependent object, both have separate copies of their dependency objects. Here, along with the dependent object, a dependency object is also cloned. That is called deep cloning. In shallow cloning, only dependent object is cloned, but the same copy of the dependency object is shared between original and cloned. Original dependent and cloned dependent objects. That is shallow cloning, previous example. This is deep cloning. That's how we need to understand. Okay, these are all better to know. Maybe you may get a question, what is shallow cloning? What is deep cloning? Can you write a code for that? These kind of questions you'll ask in interview. That's why I'm giving this code. Otherwise, I don't need to give. Please practice this code. Like I created class A and class B. You take, generally we ask in interview, employee and department. Take employee as a dependent class, department as a dependency class. Now write the shallow cloning and deep cloning code on both objects. Okay. Practice that program. First, you practice this program to get an idea. Then write two classes, employee, dependent. Employee is a dependent class, department as a dependency class. Take employee number, name and salary in employee, department ID or department number, department name, department location as attributes of dependent class, of the department class. Now, employee dependent class, department is a dependency class. Now write the shallow cloning program and deep cloning program that we ask in interview. If you practice this, you can write that code easily. This is for you to practice by looking at my code. Then the work is create employee and department, two classes. Employee is a dependent class, department is a dependency class, and write the shallow cloning program and deep cloning program by using those two classes. This is a deep cloning example. Okay. Now we want to just display the output. Output will be different now from previous to current because we have separate copies are created for the dependency object in original and cloned. That's why we are getting a difference. So this much time is taken for just completing cloning concept. Next, we'll go ahead for the other topics. Okay, let's start with.
Sir, I have one question. Hello.
Yeah, tell me.
So what is the need of the cloning?
You are in this meeting from beginning. Na? I told already, for example, you are creating a gaming application, right? Suppose you are creating a gaming application, then you, for example, you want to create enemy objects, but enemy objects looks like, for example, one hero where 100 enemies will be there surrounding that hero. Means how many objects you want? Same similar objects, 100. Right?
Yes,
So how
sir.
you can create them easily? By cloning. Create one object, clone it multiple times. So cloning will be faster. It doesn't invoke the constructor again, but you will get the same properties and same behavior in all the objects.
Yes.
That's how cloning will be. That's the use of cloning. That's where we are going to implement cloning.
Yeah. Okay, sir. Getting it.
Yeah, nice. Yeah. Now let's go ahead with the other topics now. Okay. Now, so far what we discussed is cloning. The document name is cloning, but everything I'll write here itself. Now we will understand about what is the meaning of what we can call as serialization. There is another marker interface called serializable. So we'll understand about what is serialization. We'll understand about what is serialization, what is deserialization. Okay. So that is the concept next. Then we'll understand about what is enum. Enum doesn't take much time. Enum just only a type that I'll explain about when do we create enum and how do we create enum, all these kind of things. Okay, right. First, we'll understand about a concept called as what is serialization, what is deserialization, and how it works. Okay, good. Basically, serialization is nothing but converting the object into a stream of bytes, so that we can store that stream of bytes into a file, or even we can transfer over a network, or even we can store it in a database. So the process of converting an object into a byte stream I mean a stream of bytes, that is process is called serialization. So we are going to understand that concept now. Serialization, deserialization, these things we are going to discuss now. So let's talk about serialization and how we can serialize an object. We are going to see. So we are going to understand about what is a serialization, deserialization. Okay. Now, first let us try to find out what is serialization. Okay, first understand what is serialization. Serialization is nothing but it is a process of converting an object into a stream of bytes, which can be easily saved to a file, or we can transmit over a network. Otherwise, we can store in a database. Okay. So that is actually called as serialization. Deserialization means reverse process. Means byte stream is converted into back to the Java object. That is called deserialization. So we have the two concepts in Java called as serialization and deserialization. So we are going to look into that. Okay. Right. So when we generally serialize in Java object, suppose you want to save the data of an object in a file, and later you want to use the data of the object. I think, but first I have an object now. I want to save it in a file permanently, and later I want to get back the data from the file, and I want to restore it back to the object, and I want to use the object. So then I need to apply serialization. Or suppose if I want to send object in the network from one machine to other machine, then also we apply serialization only. First, what object is converted to a byte stream of bytes. Then these are transmitted over the network to other machine. In the other machine, again, this stream of bytes will be reconverted back to object, which is nothing but object is transferred over a network. That's where serialization is required. Okay, basically when you want to store in a file, when you want to store the state of the object in a file, and at a later point of time you want to use that state by converting back to the object, that is a one way. Other ways, when you want to transfer from one machine to other machine, any Java object you want to transfer from one machine to other machine over a network you want to transmit, then we apply serialization concept. And there is a marker interface called serializable. Okay, serializable is a marker interface, like a clonable. Okay, serializable is marker, serializable, clonable. These are marker interfaces. And if you want to serialize any object, the class of that object must implement a serializable interface. Then only the objects of such class are eligible for serialization process. Means they will get additional behavior. All objects cannot be serialized. Again, serialization logic will be taken care by JVM. But how does JVM can identify that is these objects are qualified, or these objects are qualified for serialization? It will check whether the class of this object is implementing serializable interface or not. If it yes, then JVM starts serializing the object, converts the object into a stream of bytes. So cloning process, serialization process are in the hands of JVM. But how does JVM know whether these objects are eligible to do this process? That's how marker interfaces are there. It checks whether the class of this object is implementing that interface or not. If yes, it starts applying that feature. Otherwise, no. That's how marker interfaces will help to add some additional behavior for the objects, or additional features are applied for the objects. Okay, so first let's understand about what is serialization. Serialization means we have a Java object. It is converted to a stream of bytes, and the stream of bytes can be stored into a file, or it could be stored into a database, or it could be transferred over a network. So serialization is the process of converting a Java object into a stream of bytes. Is the process of converting a Java into a stream of bytes. Okay. So which can be okay, which can be easily saved to a file. Okay, right? Which can be easily saved to a file. Otherwise, transmitted over a network. Or stored in a database. Generally, we save in a file only, not in database. I mean, we can store in database also, but generally we do it with a file, or we'll transfer over network. Right. Okay. So what is deserialization then? Deserialization is a reverse process. Deserialization is a process of, otherwise is the reverse process of serialization. It means a stream of bytes are collected from a file or database or network and reverse converted, again converted back to the object. Converted back to an object. So this is called as deserialization. So reverse process of serialization is called deserialization. So basically when we do serialization when you want to transfer an object over network from one machine to other machine. Right? Or when you want to save the state of an object to a file and you want to use it for later. So we serialize an object or a Java object. Right? We serialize a Java object when we want to save the state of an object. State means data. State of an object. When we want to save the state of an object into a file and and to use it later. Okay. Or you want to transfer an object or when we want to send an object from one machine to other machine. When we want to send an object to another machine or to another process. Okay, so then we are going to apply serialization concept. So if I want to serialize an object, just my class has to implement serializable, which is the marker interface. So to serialize a Java object, okay, the class of that object, okay, should implement. Who is that marker interface? Should implement a marker interface. Who is that marker interface? Java.lang.serializable. Okay, to serialize a Java object, the class of that object should implement a marker interface java.lang.serializable. Sorry, not lang, java.io.serializable. I'm sorry. It's not from lang, it is from IO. Clonable is from lang, but serializable interface is from java.io. It should implement from so and so. Okay. Now, let's see how we can able to serialize an object. To serialize an object, we are going to make use of object output stream. One class is there in java.io package, input output package. And to deserialize, we use the object input stream. Okay. Object output stream and object input stream are the two classes we use to serialize and to deserialize. For deserialization, we use object input stream class, and for serialization, we use object output stream class. Okay. Because serialization means what? Converting the Java object into stream of bytes. How can I do that? There is a method in Java, write object method, that will convert the object into stream of bytes. That method is given in which class? Object output stream class. That's why we use object output stream class for serialization. And to convert byte stream into Java object, there is a method required called read object. Read object method is given in which class? Object input stream class. That's why we use that class. So there are two classes we are going to use now. Let me write the two classes what we are going to use. The two classes what we use. So we use object output stream class. Object output stream class. Object output stream class for serialization. And object input stream class for deserialization. Okay. Why? Object output stream class is a method called as write object. Okay. So I can say the write object method. There is a method called write object. I'm writing method. Okay. The write object method. It's a method of object output stream class. The write object method of object output stream class converts a Java object into a stream of bytes. Similarly, there is a method called as a read object. Like write object method, we have read object method also. So read object method of object input stream class. Converts a stream of bytes into a Java object. That's how we are going to use two classes required in serialization and deserialization. One is object output stream and second one is object input stream. Okay. Let me first copy this into the document. Let me copy this into the document. This image, I want to keep it in the document. Okay, done. So we got something like this. Next. Now, so you have a Java object. Then there is a class called as object output stream. Object output stream converts the object into a stream of bytes, right? And that will be stored into either a file or a database or a network, or we can transfer over a network. So which means if we write in the form of a diagram, the diagram will look like in this way. So suppose you have a Java object. Okay, you have a Java object. Let's say this is your Java object. And there is a class called as object output stream. There is a class called as object. This is called serialization, object output stream. You have a Java object. There is a class called as object output stream. It will convert into stream of bytes. This is the Java object. Let's say this is Java object. And let's say this is the object output stream class. And this is converting this Java object into a stream of bytes. Okay, it converts this object into a stream of bytes. Okay, let's say it is a stream of bytes. Or byte stream, what I can say, a stream of bytes, which is called byte stream. And this stream of bytes can be written into a file, can be stored into a file, can be saved in a file. The stream of bytes can be saved in a file, or can be stored in a database, or they can be transferred in a network also. They can be sent to a network to transfer to another processor, another machine over network. That's how it is. Okay, so this is actually called as serialization process. That's how serialization you can understand with the help of a diagram. Okay, Java object, object output stream class. It will convert this object into stream of bytes, and these stream of bytes can be stored into a file or a database or network. This process is called serialization. And what is deserialization now? You have a stream of bytes in a file or database or network, get the stream of bytes from there. Then through object input stream, it is converted to Java object. If I use reverse arrows, it is going to become deserialization. So I'll copy this same diagram once. I'll keep it here. Now let's understand deserialization. So what is happening now? The arrow is reverse now. This arrow is going to be reverse. We'll keep the reverse arrow. Okay, we'll keep the reverse arrow. Just I'm changing the arrow side. Let's move on to reverse. The reverse arrows now. Okay, stream of bytes are collected from this, a file or a database or a network. Then through object input stream, not object output stream now. Stream of bytes are reconverted to Java object through object input stream. Reconverted back to Java. This process is called deserialization. The first process is called serialization. This is called deserialization. So I'll make like this. This is called serialization. And the second process, this is called deserialization. This is called deserialization. Okay, that's how we are getting serialization, deserialization. Let's copy these diagrams as well into the document. Okay, that's how it works. I'll keep the diagram a little bit shorter. Okay, now you can understand easily. Okay, this is how the serialization deceleration is going to happen. Okay, cool. Now we need to write code for this now. We are going to use two classes. One is object output stream. It has write object method. There is object input stream, which is having read object method. So just I will show you how we can able to write the code. Okay, like we'll take some class. Let's say, for example, we'll take employee class, which implements serializable. And we will discuss about how we can able to serialize and how we can able to deserialize. Okay, now we are going to understand that now. Let's start with that. So I'll start writing the program for this now. What is serialization example for serializing and deserializing? I'm going to start writing the code for both the things like serialization and deserialization. Correct? I'm going to write the code for that. To do this, we'll start with the coding. I'll take employee class and we will start doing the work now. Okay. Yeah, sure. So first, let's start with example on this serialization. I'll talk this example. I'll talk about this example. Then I'll copy the code. So we'll start with example. Let's say I'm writing a program for serialization. So serialization program. We are in the same program. We are just doing two things. We are doing serialization. We are also doing deserialization in the same example. Let's say we want to create a new Java project, which is for serialization. Okay, we want to write a new program. This is for serialization program. We'll understand about what is serialization. So serialization program. Let's click on finish now. Okay, let's start with the new class. Let's say the package name com.ashokit. Serialization. Or let's say simply demo. Okay, class name is main with main method. Now about this, I wanted my class called employee. So class employee implements serializable. So serializable is a marker interface from java.io. You can see the output, import statement on top at line number 3. Okay. And okay. So there is a class implements, and I can take multiple properties, but I don't want to take multiple properties. I just want to take something called as what I can say employee number and name. Otherwise, whatever it is. So let's say, for example, int employee number. I want only employee number and name. I don't want to take many things. Just employee number and name, employee class. And I can define a constructor using the two fields. Then I want to over a toString method. That's it. I don't want to generate setters and getters because I'm not making them as private variables. If I make them as private variables, then I must define setter and getter. So in order to set the value or in order to retrieve the value or fetch the value, right? Read the value. But I'm not making them as private. Simply I'm writing as default modifier. So let's create constructor employee with int employee number, comma string ename. So this dot employee number equal to employee number. This dot ename is equal to ename. Okay. So yes, I got employee number and employee name. Now I just want to override the toString method. Okay. Let's start with the toString method. I want to override toString method. Go to source, generate toString method. I don't want setters and getters, only toString method is enough. This is my employee class. Remember, if you want to serialize objects of a particular class, the class must implement an interface called serializable. So that's what I'm doing here. Class employee implements serializable. Now, I'm just going to talk about all the serialization process in the main now. In the main was what I first want to create employee object now. Employee ID and employee name I will pass in the constructor to create employee object. Then I will do serialization. But while doing serialization, because of we are using input stream and output stream, we may get IO exception, file not found exception. Okay. That's why what I can do is I can write try catch blocks. That's okay. I can write try catch blocks. Otherwise, I can also throw exception in the main method, whatever that we want. Okay. And second thing is we can write try catch blocks. Otherwise, we know in core we learned about a concept called the try with resources. Right. So we can also use try with resources. Okay. So let's write the code like this now. With the try with resources, we will write now because we have discussed this a long back, so that it's going to be a recap for you as well. So first, let me create employee class object. How do we create employee object? Employee is equal to, or E is equal to whatever it is. Okay. Employee EMP is equal to new employee. Of employee number, let's say, okay, let's say employee number is 7788 or 7878. Employee name is Scott. Enough. Now I'm writing try of, try with resources, we write like this only. Through object output stream, we can serialize and we can store in a file, right? We are not using database, or we are not going to send in network now, but we can save to a file. To write into a file, we need file output stream object. File output stream object for writing the data in a file. File input stream object is to read the data from the file. So I'm going to cover both of them as well. So try with resource also I'm covering now. So first see file output stream. Let's say, for example, file out is equal to new file output stream of file location. Let's say the file is located in D drive of my computer, and use / employee.scr. SCR means serialized file. Generally, extension can be .txt also, but for serialization files, we use extension .scr, which means it is a serialization created file. It's going to create in D drive now. Actually, the file is not exist. It's going to create now. Don't worry. And I say semicolon, because I'm applying try with resources now. Then object output stream. Let's say object out is equal to new object output stream of file out. Then start the try block. Import the object output stream. Okay. I want to tell you now, there are two resources I'm using in try block. What's the advantage of try with resources? We don't need of writing finally block. Whatever the resources used in try statement, those resources are automatically closed even though exception occurs. That's what the concept of try with resources. Okay, we are trying to execute a block of code with the given resources. During execution, if any exception occurs, those resources are closed first. Then control goes to catch block. So there is no need of defining finally block in order to close those resources. So that's what the concept of what try with resources. Correct? This we discussed in exception handling topic. The two resources I'm using is file output stream object and object output stream object. Both objects will be closed automatically once a try block is completed successfully or with exception. In both the cases, they are automatically closed. So I no need to write separately a finally block in order to close these objects. That's why I'm writing try with resources. Okay. Out dot. There is a method called write object. And I'm passing the EMP. And for try, I'm writing catch block. Catch IO exception. Input output exception, IE. And you want to print the exception, then you know already exception handling very well. Print stack trace is a method. Okay, so whatever so far I've written here, this is all serialization process. Okay, this is totally called what, guys? Serialization process. Whatever I written so far, that is serialization process. Starting from try block, line number 30. Next, we'll start deserialization process in the same example. Deserialization means reverse, converting back. So let's do one thing. First, we'll take one employee reference. This is deserialization process. Let's take one thing. Employee EMP deserialized, otherwise deserialized EMP. Any word equals to initially null value I'm putting null value. Initially, because I want to get back now. So initially it is null, we'll get the object. Through the deserialization process, object is created. Object can be created through deserialization process also. Now again try block with resources now, try with resources. Because this time you have to use file input stream, not file output stream. So file input stream. File in equal to new file input stream of file input stream is for reading the data from the file, right? Location of the file is d:/employee.ser semicolon, the other resource. And as you know, we also need is object input stream. Let's say in is equal to new object input stream of file in. Then I'll start the try block. Okay, hope you got my point now. The reverse concept now. Okay, because deserialization now. Now we have to call the method called as a read object, but the return type of read object method is object. So we have to typecast into employee type. So what I can say, deserialized EMP is equal to employee of in dot read object. Okay. Now I want to catch two exceptions here in the catch block. One is IO exception, or second, there may be something called as class not found exception. For example, if in the deserialization process, if employee class not found, we make a class not found exception also. So we know that multi exception catch block. That also I told you in exception handling. If you go back to exception handling topic, means with a single catch block we can handle multiple exceptions. That is called multi exception catch block. So let's say IO exception or type symbol class not found exception. let's say IE or REX, and display the exception stack trace if anything occurs. So then I want to simply display the system.out.println deserialized employee. Now, first of all, tell me, is this code? Did you guys understood this code? Or you have any query at any particular point? Did you understood this code, or do you have any query on this? So total serialization, deserialization code is inside this main is visible to you. And you guys can tell me if you have any query on this, or is the code is okay? Is the code understandable to you? I have covered here object output stream, object input stream, file output stream, file input. File output stream is for writing the data into the file. File input stream is to read the data from the file, get back the data from the file. So do you have any query on this? Do you have any query on this, or is this good? Is this good? Okay, this is good, right? Okay, now let us run. This process is called serialization. This process is called deserialization. I have covered like file input stream, file output stream, try with resources once again, multi-exception cache block once again. Okay, that's what I have written the code here. And we are serializing the object of employee, and also we are deserializing to get back the employee object. That's how I'm writing the code. Okay, just we'll get the deserialized employee data, but the process is important. And you can see there is a file created in D drive. In D drive, there is a file created. Let's go to D drive of my computer. You can see there is a file created called employee.ser. There is a file created called employee.ser in D drive. Correct? This is a file. And of course, if I open the file, now I can open through Notepad or whatever, because it contains a stream of bytes. Notepad is an application. It cannot show the stream of bytes correctly. If that application is not a suitable application to show the content, we may get some kind of data like this. Okay, we may get some kind of data like this. Okay, but the thing is now this is our Notepad. Notepad application. Notepad is an application for text. Notepad application is not a suitable application to show the stream of bytes. That's why when I open that, you are getting some output like that, but actually they are stream of bytes. Just only file is created or not. That's it. If you know that is enough. Okay, and your object is you are getting back your employee or not from that file. That's enough. That's how it is working. Now, for example, if I run the program again, okay, object is deserialized. We are nothing to worry. It is deserialized and we got the response. 7878 is employee name is Scott. That's it. That's how we need to understand. Next. Okay, first let me copy this example for you. These import statements for your reference. These are all the import statements for reference, and finally, you will get back your employee. That is, this example is containing both the processes, serialization, deserialization. Now, in this, there is a variable that you need to understand that is called serial version UID. Generally, when you are creating any class which implements a serializable, we'll create a private static final variable called serial version UID. So you need to understand, what is the use of serial version UID? and it is of type long. Generally, whenever we implement a class from serializable interface, okay, we are going to create one unique identifier for serializable classes. That identifier name is called serial version UID, which is of type long. We declare as private, static, and final. Now we have to understand what is this serial version UID. Okay, so let's understand about what is serial version UID. Okay, generally when we create one unique variable or identifier when we are creating serializable classes. Okay, let's start with. Yeah, just 1 minute, guys. Okay, I'll continue. Just I'll drink water and continue. Yeah, guys. Actually, it is one unique identifier. Whenever we implement a class from serializable interface, okay, we are just going to add one. We are going to add one unique identifier in the class called serial version UID. Okay. So what the use of this is, at the time of deserialization, okay, so this serial version UID will play a role because the sender and receiver of the serialized object, whether both have loaded the same classes or not, means nothing but, for example, I have an employee class. While serializing, I have an employee class with ID and name. But while deserializing the employee class, for example, I have ID, name, and salary also. There is one more employee class is created with the 3 properties. Both are employee classes only. And both are from 2 different packages. One employee class is in package 1, and another employee class is in package 2. But they are 2 different versions. Then deserialization may fail here. That's why this serial version UID will be used to verify whether the same class is used at the time of deserialization or not. Because at the time of serialization, one employee class is used. At the time of deserialization, another employee class is used. Then they mismatch. Okay, that's why it is, whenever suppose when object is serialized, the serial version UID will be included in the serialized data. And during the deserialization, JVM will check whether the serial version UID of the loaded class and the serialized object. If they match, then only deserialization will proceed. Otherwise, exception will be thrown, invalid class exception. That's where serial version UID comes into a picture. Okay, which means it is like, when we are serializing an object, this ID will be, this serial version UID will be included in the data. And at the time of deserialization, JVM will check first. What is the serial version UID in the class and in the serialized data? If both are matching, deserialization will proceed. Otherwise, it will throw invalid class exception. For that reason, serial version UID will be used. That's the importance of serial version UID. That's why at the time of creating any class which implements a serializable interface, we create one long variable called serial version UID with modifiers as private, static, final. Okay, so let me add some points on this. The purpose is like that. So let me add the purpose now. Okay. So what is now? It is a unique identifier for each class that implements a serializable interface. So I say, for example, the serial version UID is a unique identifier for each class, okay, that implements serializable interface. Okay, and it is declared as a private, static, final. It's a long variable. It's a variable of type long. We use long type, not integer, long type. Okay, and it must be declared as private, static, final. It must be declared as private, static, final, long variable. Let's say, for example, private, static, final, long, serial version UID equal to 1L. L means long, na? 1L. Just one I am writing, L for long. So now I just want to write one point regarding why it is important. That is answer for this question called what is that. So in our previous program also, I can add here. What I can take in my previous program, I can take in my employee class. This is the class implement serializable. So here I can write private, static, final, long, serial, version, UID equals to 1L. I can write like this. Okay, generally when a class implements serializable, it is recommended to add this attribute called serial version UID. You can identify before writing this property, I have a yellow mark here, like warning. But after writing this variable now, that yellow mark is gone. Or if I keep this comment, if I keep this line in comment, you can see that my class is getting one yellow mark. The serializable class employee does not declare a static final serial version UID field of type long. It's a warning, not an error, but you got warning. But after declaring, the warning will be gone. It's recommended to do that. Okay, it is recommended to do that. Now, next, nothing to do, just only create one variable like this. Then JVM will take care of remaining things. So I'll tell you what it will do. So when an object is serialized, okay, when an object is serialized, the serial version UID will be included, is included in the serialized data. Okay. Now what happens during deserialization? So during deserialization, JVM checks Okay, during deserialization, then the JVM checks the serial version UID of the loaded class. Okay, of the loaded class and the serialized object. If they match, deserialization will proceed. Okay, will proceed. Otherwise, JVM throws invalid class exception. Okay, so that's how this variable plays a role. And better to know what is this variable called serial version UID, because you learned about concept called as serialization. Okay. Next, I told there is something called as enum. Actually, enum is one. Enum is a keyword for creating one enumeration type. Better, I will explain about this in the further when we are discussing in advanced programming. And you have from Wednesday, I'll start advanced Java at evening 5:30 from next Wednesday. So in advanced programming, definitely we need to use this enum. But I will explain you at least something about enum now, but I'll explain more about enum in
Sir,
that
at 6
advanced
o'clock we
programming.
have Oracle class, sir.
That you need to adjust. Have no idea about that, but we fixed a batch at 5:30 on from Wednesday. Tomorrow is Monday, na? From Wednesday at 5:30, I'll start. In a month, I will complete. Actually, I kept a long leave. Okay, for my job for 2 months. That is going to affected from tomorrow Monday. So that's why I'm taking that class at 5:30. Otherwise, time is even not possible for me. But okay, I'll cover in a month to 40 days max. A month only, even 4 days is not required. I'll cover all the JDBC, Servlet, and JSP, that 3 technologies in a month. I'll start on Wednesday at 5:30. If you have any other class clashing, try to adjust the timings. Okay, because again, advanced Java I won't take in a nearby time. So try to adjust to some other, change your, suppose if any class is clashing, try to attend in another batch. I mean, if any parallel batch is going on in some other timing, so try to adjust your Oracle to some other time. Okay, that Oracle knowledge also required in advanced Java about the queries like insert, update, delete, select, and all. Okay. Back to enum. I just want to explain a little bit about enum, but I will explain more in detail when we are working with advanced programming. Actually, enum is to create one enumeration type. The thing is now, when you want to create a variable, okay, when you want to create a variable and you want to assign a fixed set of one of the fixed set of values to the variable. Let's try to understand what is this. For example, just for example, I am creating one variable called string. I want to create one variable called string. Variable name is day. Day is a variable. String is the data type. But what can I store in day now? Actually, my intention is in this variable, I want to store a day, like from Monday to Sunday, whatever Monday I want to store. Can I store Monday in day? Can I write day is equal to in double quotes Monday? We can write. Correct. we can add day is equal to Monday. In double quotes, I can add day is equal to Monday. Correct? Similarly, I want to write day is equal to hello. Day is equal to Monday is correct. Day is equal to hello. This is also correct. But hello is not a day. Both are correct. I won't get any error. Both are correct. But the thing is, I don't want to store hello or hi or any other string. I want to store only a day, a valid day from Monday to Sunday or Sunday to Saturday, whatever. I want to store one of the day from Sunday to Saturday. For that, I created one variable called day. But now it is allowing me to store Monday as well as hello also. So when you have a requirement that I have a fixed set of values, we have a requirement that I have a fixed set of values, right? Correct. What I'm saying now, I have a fixed set of values. Now what I want to do, so I have a fixed set of values. Correct. I have a fixed set of values. And I want to store one of the value or one of the values to my variable. Okay, so then you need to create enumeration type. And for creating enumeration type, we have a keyword called enum. Now for the same example, let's say, for example, you please go through more on enum. I'm giving it like a work for you, but I'm explaining the basic. For example, I'm creating enum. There must be some name. Enum is a keyword for creating enumeration type. Let's say, for example, day. First, inside enum, you must create the fixed set of values. What set of values should come under this type? And write them in uppercase letters because they are all by default static and final. The values are static and final. The enum values are by default static and final. They are static final values. Let's say, for example, Monday, comma, or Sunday to Saturday. Sunday. I'm not doing all Sunday, comma, Monday, like that up to Saturday. I'm not writing everything just for explanation. Okay, then I can close. At the end, I can keep semicolon, but semicolon is mandatory or optional means optional. If you want, you can make it as semicolon, otherwise you can leave it also. Now you create a variable of type day. For example, I'm writing now day, semicolon. Day is a one enumeration type, and you are creating a variable for enumeration type. Now this variable can store any one value from Sunday to Saturday. How to store now? These are the fixed set, and this variable can store only one value out of the fixed set of values. Let's say, for example, I'm writing day is equal to day dot Monday. Because they are static final, I told you. The value I can assign is Monday. Day dot Monday. I can assign like this. Or day dot Saturday. Or day dot Sunday. But I can't write day is equal to hello or how are you. Okay, I just gave you a basic idea on enum. In this situation, we are going to create one enumeration type by using a keyword called enum. First, you create one enumeration type. Then you create a variable for that type to store one of the fixed set of values. So first I'm creating enumeration type using enum keyword. Then I'm creating a variable of type enumeration type. Then I'm storing one of the values. That's how it works. That's how it works. that's why we are going to use enum. Just please go through it, and anyhow in advanced session, if I'm again going to talk about enum separately. Meanwhile, you also try to learn yourself about this enum. It is for creating one enumeration type. Learn enum. I gave a basic idea, and you just explore on enum, and I will also once again explain when we are in the advanced technology, in the advanced Java class. Okay. That's how we want to conclude this session, and we will continue with some other small topics, whatever is, if anything, anyhow that we are going to use in advanced Java. So there I will explain about those things as well. Okay. Please go through it. Okay. So I'm just going to wind up the class now. Let's meet again in advanced Java class Wednesday at evening 5:30. You will also get a message regarding this advanced Java class.
Sir, when will you be leave?
Sorry.
When will you be going to take leave?
Leave in the sense not for Ashok IT.
Okay.
No. I kept one long leave for my company, and I will continue the classes in Ashok IT for the evening session for the next approximately for the next 2 months.
Okay.
So that's why evening 5:30 session is okay for me. That's why I'm able to take 5:30 at evening.
Okay. After that, you will be not taking it evening session. You are
Evening
saying?
session means I will take from 7. Okay.
Okay, sir.
Got it. Okay.
Why? Because
So
we are having good class at 7 o'clock only, na?
no,
That's
that
why
is
I'm
okay.
asking.
That's why I started at 7. That is okay. That is for that no issue for me. But for 5:30 timing, I'm talking about 5:30 timing. So that's why I'm starting advanced Java at 5:30. The advanced Java batch will be at 5:30 from next Wednesday.
Okay, sir. Okay.
Okay. Okay, guys, I'll wind up. First of all, I'll share these notes now in the chat box. Please download it. Today's notes, cloning, all examples, everything. First, let me serialization and all these things that you learn. I'm just going to share it in the chat box now. Please download now. Just a minute. I'm going to share the notes now.